Yes, good afternoon, my good friends out there. I still remain Dr. D.I.Ju, your chemistry lecturer on social media. All along, we have been dealing with gas laws. And in our previous lessons, we have so far so good treated Boyle's law, South's law, and calculations based on them. We have equally treated general gas equation and also ideal gas equation. And we have also calculated some problems based on them. We are still undergoing these gas laws. But today, we will treat another gas law titled Dalton's Law of Partial Pressure. Dalton's Law of Partial Pressure. Please listen carefully as I go through my notes before I explain what you are seeing on the board. Now, the law states that in a mixture of gases, please listen very carefully. The law states that in a mixture of gases which do not react chemically together, the total pressure of the mixture of gases is equal to the sum, that is the total, of the partial pressure each gas would exert if it alone occupies the whole volume of the container at the same temperature. So this could be represented as it is here. Look at it. It says, when a mixture of gases which do not chemically react together are in the same container, each of them will exert a pressure based on the molecular collision that is prevailing. But the total pressure of the gases in that container will be the sum or the addition of the partial pressures of each of these gases as if when they were on their own separately. Look at this here. A, B, C. These are gases. Gas A, gas B, gas C. Now, gas A also exerts a pressure. Gas B will exert a pressure. Gas C will exert a pressure. Gas D, E can continue. Now, to find the total pressure of the gas inside that one container, it will be the sum or the addition of gas A pressure, gas B pressure, gas C pressure. If there's any gas D and so on, that will give you the total pressure of the gas. That's what it means by the law of what? Partial air pressure. So, from this, the PA is the partial pressure of gas A. The PB, partial pressure of gas B. PC, partial pressure of gas C. That is. Now let's continue. Note that the pressure is constant gas exhibit or exerts is called the partial pressure because the gas are not miscible. They cannot miss. So everybody is exerting on its own. So the force that each one is exerting is called the partial pressure of that particular gas. And it is equal to the product of the mole fraction and the total pressure. You see that? It is what? Equal to the mole fraction and the total pressure. This can be represented mathematically as this. Now look at it here. To know the partial pressure of gas A, because they are already in a container. So how do you determine the pressure of A and B and C individually? So the partial pressure of A or B or C can be calculated by what? The number of moles of the gas A, for example, we are using gas now, gas A, all over total number of moles of gases in the mixture times the total pressure. Listen carefully. We are looking for now an individual gas pressure. Let's take A now. So the individual gas pressure of A will be equal to the number of moles of the gas A all over total number of the moles of the gases in the mixture times total pressure. All right. Now, let us continue. Now, this expression we are seeing here now, this expression that can be seen now, we can bring it out vividly. So your PA will be now number of moles of gas A plus the number of moles of gas A plus number of moles of gas B plus number of moles of gas C times on total pressure. So this expression you are seeing is called mole fraction of gas A. If it is the B we are considering, it becomes mole fraction of gas B. If it is the C we are considering, it becomes mole fraction of gas C. But we are now using A as an example or as a specimen. So what you are seeing now, this expression, which is PA equal to NA all over NA plus NB plus NC times total pressure is what? Mole fraction of gas A. Okay, let's continue. Now, and this is called the ratio of the number of what moles of A to the total number of moles of gases present in the container. This expression now, which we call mole fraction of gas A, is the ratio of the moles of the gas A to the number of what? Total number of moles of the gases present in the container. So it is if a gas is now collected over water. Sometimes we see hydrogen or carbon dioxide is collected over water. So if a gas is collected over water in the preparation, most likely it will have some water vapor that will saturate it. And if that happens, how could the pressure be determined? Look at it here. Total pressure at that time will be what? Pressure of the gas plus the pressure of the water vapor. Now, we are looking for the pressure of the gas to now becomes total pressure of the gas minus the gas pressure, which is the water vapor. When you have done that, you will get the pressure specifically of the gas in question. Now, listen to this last paragraph before I draw the curtain. According to kinetic theory of gases, the molecules of two or more different gases at the same temperature have the same average kinetic energy, and that no attractive forces exist between the gas molecules that do not react chemically. Let me bring it again. According to kinetic theory, we say that at temperature and at a pressure, molecules are moving. There is a frequent molecular collision among themselves and among the container. We are now saying that when two or more gases are in a container at the same temperature, the molecular collision of the individual molecules will remain the same. Even though they are not mixing together, the movement is the same. And because they are not mixable, there's no force of attraction that will ever bring them together to mix up together. So chemically, they're not reacting. So that is kinetic theory. So please like it, share this video, follow me, and also subscribe to my YouTube.